All right, so our home plate for today is page 398, numbers 19 and 20. Also, the following 6 problems, it says only, bam. Instructions, rewrite the function if possible, graph, and identify domain and range. Rewrite the function if possible, graph, and identify domain and range. First one is g of x equals 2x minus 5 over x minus 2. Number 2, g of x equals 3x minus 5 over x minus 3. Number 3, g of x equals 6x plus 2 over 2x plus 1. Number 4, g of x equals 8x minus 3 over 4x minus 4. Number 5, g of x equals 1 over x minus 3 squared plus 2. And number 6, g of x equals negative 1 over x squared minus 2x plus 1 plus 3. All right? We good? All right. So, I don't know if you noticed, we're getting into quadratics now. Yeah, let's go. Our objective for today, I can write, solve, and graph rational functions. I can write, solve, and graph rational functions. So, we're just continuing on with what we've been doing with rationals. Now, like I said, the book that you have, they try to throw everything in 1 or 2 lessons, and I just think it's a little bit too much for one. So I'm going to break it down so that we can see certain things. Hopefully that'll help you as we get to where we need to be. Okay? If you have your colored pens, have those ready, please. Pretty please. With a cherry on top. If you don't have one, go buy some. If you don't have money, go wash a car or clean a room or something. Your couches, go clean them. There should be like some quarters or something in there. All right. So rational functions, we know what they are. They are equations that have at least one rational expression in them. There you go. All right. Steps that we covered for graphing were the top 4. The last part were for the last problem that we did. We're going to revisit this today. And once again, to recap, we started with transformations last semester, which is this one. And the second one, general rule for transformations, is for rationals. And what did we say the h and the k were now for rationals? They were also what? Asymptotes. And what, in other words, what are asymptotes? An invisible line that we get close to, but we never touch. Bam. Which one have we been working with? Vertical and horizontal. And guess what? Tomorrow we're going to get into the funner ones, which is obliques. So please, pretty please, do your home plate. Don't copy from people. Just a suggestion. So once again, this is how we get our vertical and our horizontal asymptotes. Yes? Just by looking at it, we're like, oh, there it is. So tell your neighbor the vertical and the horizontal asymptote of that one. Yeah, just by looking at it, the vertical, this is supposed to be a negative right here. But since it's a positive, then our vertical is negative 2. What is our horizontal? Negative 3. Okay. So, vertical, negative 2. Horizontal asymptote, negative 3. Negative 2 of x is right here. A vertical line there. Negative 3 of y is down here. And here's my graph. Piece of cake. Now, some of you are still wondering how Mr. Q does it to just graph it like that. Here it goes again. We started off with a parent function, f of x equals 1 over x. What did I tell you the graph for this one looked like? It looked like this. And I said that never changes. By looking at this, the x doesn't have a number next to it, so the vertical asymptote is x equals 0. And it doesn't have a constant right here, so the horizontal asymptote is y equals 0, which looks like this. Are we there so far? All right. From there, we added transformations. G of x equals 1 over x minus 3. What happens to this, and very good that you're paying full attention, appreciate it. What happens with this whole function, including the asymptotes, according to this? Tell your neighbor. Very good. It moves the whole thing 3 steps to the right. So instead of being here, the asymptotes and the graph, it goes how many steps to the right? 1, 2, 3. So my new asymptote is here and here, and my graph moved to this spot. You're like, oh, here goes another. G of x, equals 1 over x plus 5 minus 2. Tell your neighbor what happens to the original function, including the asymptotes, according to this transformation. Who said 5 to the left and 2 down? Yeah, the whole thing moves, the asymptotes and the graph. So 5 steps to the left, 1, 2, 3, 4, 5. 3 steps down, 1, 2, 3. So there it is. All I asked you to do is to make a table and show me points. But it's the same graph. It moves around, including the asymptotes. Does that make sense? Am I talking crazy over here? No? All right. And then I said, what if I give you something like this? G of x equals negative 1 over x. Tell your neighbor how that graph looks. The original, by the way, the original was here and here. With the negative, it does what? It reflects about here and here. That's if it has a what? A negative. So, any questions with these? But then we got into these funner ones. We went from here to here. So I'm going to do one more of these together. Copy that one, please. Get your color pens ready. One more of those. G of x, example 1 mega q. It says rewrite the function and graph, and then identify the domain and range. So here we have g of x equals 5x minus 7 over x minus 2. Once again, g of x equals 5x minus 7 over x minus 2. What did the steps say here to do? The steps that I gave you guys. It says use long division to rewrite it. Here we go. I'm going to zoom in, and I'm going to use long division. What's our dividend? 5x minus 7. Divided by, what's my divisor? X minus 2. All right, I'm going to switch to blue. What number times x gives me 5x? 5. 5 times x is 5x. However, it has another term. What is 5 times negative 2? Negative 10. Now, let me show you some of the mistakes that I saw on the home plate. Look up. When you subtracted here, you forgot to distribute to here and to here. You need to distribute to both the negative. So that means this cancels. This turned into a positive 10. So what is 10 minus 7? 3. That's my remainder. Some of you ran that. If you were driving, some of you ran the stop right there. All right, here we go. So what's my whole number? 5 plus, what's my remainder? 3, and what's my divisor? X minus 2. All right, Mr. Q, that kind of looks like what we've been doing. Yeah, but what goes first? The fraction and the constant at the end, right? That means I'm going to rewrite this fraction in the first term and the constant in the last term. What allows me to do that? The commutative property of addition. What does that mean, Mr. Q? It means 1 plus 2 is the same as 2 plus 1. That's what allows me to move these around. So let me rewrite it. This is 3 over x minus 2. What's the sign here in front of the 5? Positive 5. However, who notices that the numerator is a 3? What are the factors of 3, by the way? 3 times 1. Is that correct? So can I leave the 1 there and move the 3 outside of the fraction? Yes. So this is going to look like this. 3 times 1 over x minus 2 plus 5, and all that equal to g of x. Are we ready to graph? Okay. Is it a positive function? Yes. So can you picture the function if it's a positive one? Yes. Tell you never the transformation of what's going to happen to this function. That is correct. 2 to the right and 5 up. So let's identify our vertical asymptote. Vertical asymptote is x equals what? Positive 2, which is that. And our horizontal asymptote is y equals 5, which is the constant. All right, I'm going to zoom out. And let's graph that. Y equals 5 is up here. X equals 2 is right there. And the graph is right here. But how do you know exactly where it goes? Right now, we're not doing it exact unless I ask you to do a table. Is that correct? Then you would get points. But for right now, does that look pretty close to being the graph? Yes. Now, who notices that we have a 3 multiplying the whole thing? Yeah, what does that do to the function? It either gets it closer to the corner or away from the corner. That's all it does, according to the points. Show me your parents, I'll come to you out with these. Yeah, I guess you'd be Jedi Master, Jedi's Masters. Never mind. All right, we're good with this one, yes? All right, so domain and range. Ready? Here it goes. Domain is talking about all the x values that are part of this graph. We'll look at it. If it has an arrow and it's pointing to the left, that means that it's going to continue going to negative infinity of the x values. Is that correct? If it's pointing to the right, look at this one, it's pointing to the right. That means it's going to continue going to what? Positive infinity. However, which value is excluded from all the x values? Everyone? 2. So let me show you how to write the domain. We're no longer going to write it like I showed you at the beginning with real numbers. Now we're going to use something that we call a union. You're saying, what? Yeah, I'm going to use, interval notation, but with a union. Here it goes. Domain. It's from what? Negative infinity to what number? 2. So it goes from here to here. Yeah. Danica's leaving? What? You're not staying for the lesson? Oh my goodness. Danica. Oh, you can watch it on YouTube. And you're going to hear me say Danica. All right. So from here to here, it's up to right there. Do you guys see it? How about from here to here, what do I write? 2, comma, positive infinity. However, in order to say that these two are still part of the domain, we do a little U here, which means union. That with that, yes. We would do a bracket if we included this. Are we including the asymptote? No, because we don't touch the asymptote. That's why we do a parenthesis. Do the range. If it's pointing down, that means it's going to continue to what? Negative infinity. If it's pointing up, it's going to continue to what? Positive infinity. But what's the only y value that's excluded, everyone? 5. So my range is from negative infinity to what? 5, union from 5 to positive infinity. And that's how we write that. All right. Show me a favor from 1 to 5. How come figure out where these? Oh, you need a manicure. All right. All right. Let's go to these. Bam. I'm going to go over this one more time completely. And you're going to do one by yourself completely. But I'm going to use the colors again. There's the process again at the bottom. If you didn't copy it because I gave you that process because if you follow it to the T or to the Q, you will be able to finish the whole problem. Nice, Monse. All right, here we go. It says, example 2, write the equation of the function given the graph. Here's the graph. We need to write an equation. It says, use the form g of x equals a, parentheses, 1 over x minus h, close parentheses, plus k. So what does step 1 say? Write the general transformation rule. So they give us this one. So in red, I'm going to write the first step, which is g of x equals a times 1 over x minus h plus k. Why did I do that in red? Because that's step 1. Write the form that they give you. All right, step 2 in black. What does it say? Identify the vertical and horizontal asymptotes and substitute into the rule. Well, look at the graph. What are my asymptotes? The dotted lines. Do you see the dotted lines? Here and here. Let's start with the vertical one. Where does that cross on the x? -2. Where does it cross on the y? At 1. So here, instead of h, I'm going to substitute -2. And here, instead of k, I'm going to substitute 1. This is my VA, and this is my HA. So I'm going to rewrite this in black, and now including these values. G of x equals a, parentheses, 1 over, pay attention to this part, look, x minus, what is h? -2 plus 1. Some of you are like, why did you do -2 if we already had a negative? Because negative is part of the formula, and the -2 is where it crosses. And why do we do that? Because negative times a negative becomes a positive. Pretty much we're done. The last 3 steps is just to figure out what A is. All right? So here we go. To figure out A, step 3 says, in green, identify a given point and substitute. Which point do you want me to use? -3, 5, or -1, -3? Okay, I'm going to use this one down here, negative 1, negative 3. Instead of x, negative 1, we know this is x. It goes right here, right there. And this one is g of x, because we're not using y. We're using what? G of x. It goes right there. So let me rewrite it using those values. Negative 3 equals a, parentheses, 1 over negative 1 plus 2 plus 1. Step 3 is done. What does step 4 tell us to do? Solve for the remaining variable. What variable? A. Here we go. I'm going to do that in blue. Negative 3 equals a, parentheses, 1 over, what is negative 1 plus 2? 1 plus 1. What is 1 over 1? Let me show you here with a big 1. What is 1 times a? A, bring down the plus 1 at the end over here, equals to negative 3. Let's solve. Minus 1 minus 1. Negative 4 equals a. Now, did we have a function? Did I say that we were pretty much done? Yeah, it's over here. I'm going to take this one. And what does it say at the end? Rewrite the function and graph. We already have the graph. So I'm going to write g of x equals, instead of a, what do we write? Negative 4, parentheses, 1 over x plus 2 plus 1. Yeah? Some of your friends are coming to with these? Yeah, I'm going to give you another one so you can do that one by yourself. See if you can follow the process. Here we go. Example 2Q. Here's the graph. Find me the equation of the function of that graph. I'll give you some time. Ready, copy, and go. Hands if you got that. Let's go. Yeah, we got this, yeah? So pretty much, like I said, we're done after step 2. All we have to do is figure out what? A. All right, let's go to the other one. Copy this one. Here we go. We're going to do this one together. Some of you use the same form as the previous one for this one, but they're giving you the form to use, aren't they? Yeah. So I'm going to do this one more time in color. Step 1, rewrite or write the general form that they give us. So it's g of x equals 1 over b times x minus h plus k. Step 2, identify and substitute the asymptotes, vertical and horizontal. Here's my vertical. What is my vertical x value? Negative 3. And my y value? Negative 1. So this is negative 3. This is negative 1. Do you guys see that from the dotted lines? Yes? Okay, good. Let me substitute those. G of x equals 1 over b times x minus, check this out, minus 3. And then at the end, minus 1. Now, why did I do this? So I remember to do what? Negative times a negative is a positive. There it is. Okay. So we're done with step 2. Let's go to step 3. What does it say? Identify a point and substitute. Which point do you want me to use? Negative 1, negative 2, or negative 5, 0? Very good. Negative 5, 0 is easier because 0, you don't do anything with 0. So this is x and this is g of x. So instead of x, where do I go here? Negative 5. Instead of here, it's 0. So let's substitute those values. 0 equals 1 over b, negative 5 plus 3, and at the end minus 1. I'm done with step 3. What is step 4? Solve for the remainder. Here we go. So 0 equals 1 over b times negative 2 minus 1. Are we there so far? So negative 2 times 1 over b is the same as negative 2 over 1 times 1 over b. Do you agree with that? So this could be rewritten like this. 1 over negative 2 over b, and then minus 1. Are we there so far? So you're like, Mr. Q, that looks weird. I know, doesn't it? Let me move this closer. So yeah, it does weird. It does look weird because we can't have a fraction in the denominator. So look, I'm going to do it in red. I'm going to rewrite this over here on the side. 1 divided by negative 2 over b. Think about it. How can I rewrite that division of a fraction? 1 times the reciprocal, which is what? b over negative 2. So what is b over negative 2 times 1? b over negative 2. So this turns into that, and I bring down the negative 1 equal to 0. And I just finished solving. Continue solving for b. Plus 1 plus 1. 1 equals b over negative 2. How do we get rid of that negative 2 that's dividing? Multiply times negative 2 both sides. We're left with negative 2 equals b. Now we just need to rewrite our function using that for b. Is that correct?
Yes, Mr. Q.
All right, good. Does this make sense right here? Yeah, right? Yeah, because some of you left it kind of weird right there, and some of you got stuck. So this is, I'm showing you how to rewrite it using that. All right, so I bring down my function. What was my function? This one. But instead of b, I'm going to write the new value. So here we go. G of x equals 1 over b. What is b now? Negative 2, x plus 3, and at the end, minus 1. And that's my function. Now, if you look at it, is this a negative function, by the way? Yes, because the negative is down here now. It's going to do whatever, but it's a negative. So that means our function is going to look, oh, not like that. It's going to reflect, my bad. It's going to look something like that. Oh, wait a minute. They gave us the graph, didn't they? Oh, there it is. Damn, it's cool. Good, right? And these are good. I like these. So let's crank it up a notch. On your graph paper, copy this one. This is the last part, and this should be a piece of cake. We already covered domain and range. This is, if you notice, now we're introducing a squared on the denominator. You guys see that? All right, so on your graph paper, write g of x equals 1 over x squared. This is what the graph looks like always whenever we have a denominator which is squared. Ready? Look up. You're like, wait a minute, it looks like the other one. Almost. That would be the graph for an x squared on the denominator. And if you look at it, what is our vertical asymptote? X equals 0. What is our horizontal asymptote? Y equals 0, because there's no constant and there's no number next to the x. So here's my asymptotes. Are we there? All right. I'm going to take away the coordinate plane. You're like, where did it go? I took it away. Look up. So I can show you what it looks like without the coordinate plane. There it is. My asymptotes. Why are you doing that, Mr. Q? So I can show you the transformations. G of x equals 1 over x plus 3 squared. Tell you never what's going to happen to this whole thing, including the asymptotes, according to that transformation. It's going to move it how many steps to the left? 3 steps. The whole thing. The arrows and all that, including the asymptotes. Does that make sense? How about this one? Hold on. G of x equals negative 1 over x squared. What does it do? It reflects it. It would be right there. Are we there? All right. Because for home play, you're going to have some of these. Look up. Look at this one. You're like, Mr. Q, that doesn't look like, okay. Look at the one I showed you. Look up. It has a parenthesis, doesn't it? How can we make this one have a parenthesis? Factors of 16 that add up to 8. 4 and 4. So my factors are x plus 4, x plus 4, or in other words, x plus 4 squared. Yes? Which means I can rewrite this, g of x equals negative 2 times 1 over x plus 4 squared, and then plus 7. Tell your neighbor the vertical and the horizontal asymptote of that one. Vertical asymptote is x equals negative 4. It's right there, yes. Horizontal asymptote is y equals 7. So 7's up here. Oh, got it. My bad. Negative 4 is right here. All right. Oh, by the way, this is a what? So that means it's going to be right there. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye. Make it a family math night. Damn, let's go. Bye.